All right, so my name's Chris Pruchet. I'm the CEO and co-founder of a company called Origin. We've actually been around for about 4 years now. It's actually quite some time in the startup world. And raise your hand if you have heard about Origin before. And did you hear about Origin this time, or did you hear about Origin last year at FormNext? Okay, so a lot of people learning about Origin for the first time. Well, so our company, so my background is I used to be a software engineer at Apple, and I'm not going to give too much background on the company, the starting of it. It's pretty interesting. But we officially launched the company in November last year at FormNext, as we kind of came out of stealth. We're pretty secretive. This is the first time that we are presenting in our own booth at a conference, trade show. So you should definitely check it out if you haven't, Origin booth. And we also made a variety of announcements this week. And going back in time, since November, we've announced a variety of material partnerships, and we're going to talk about that. But we're also announced some stuff yesterday and this week as well that we'll talk about. But I want to get into the talk. So this is Unlocking Additive Mass Manufacturing with Origin. So the first thing about Origin is that we build a system for manufacturing a large number of parts. This is one of the parts we started with. We produced tens of thousands of these NFC tags almost 3 years ago. It's a really complicated part to print because it has an embedded NFC chip, multiple colors. It's essentially a product. But that's really what we think manufacturing is all about, is the combination of processes to produce an end-use product. So today I just want to talk about like 3 rough bullet points. I want to talk about something that we really believe in. That's just a foundational aspect of Origin as a company, and that's that we have an open material ecosystem. Origin is open in general. That's not open source. Open as, and we partner with companies, and we allow customers to create technology on our platform, and we allow material companies to create technology on our platform that benefits everybody. If you think about in the high-tech world, open platforms have done a lot, and so we're going to talk a lot about that. 2 is I want to talk about something that we introduced this week that's at our booth. And it's sort of the missing piece of having this open ecosystem. And then 3, I want to talk about case studies at how we're working with some companies to power their sort of mass scale production, additive manufacturing. Go through this. So we think as a software engineer, open platforms change everything. You had cell phones are incredible. 3D printing is incredible. The iPhone came out, it had a couple apps on it, had a great interface. It really wasn't until the App Store came out that the iPhone got interesting. Apple can't make all the apps in the world, right? As an ex-Apple software engineer, we tried when I was there. The App Store was a really great idea. And a lot of people think the iPhone's not open. I argue that they've controlled it, but it is open. You can develop an app for it. Android, on the other hand, is open source. So they'll go a little bit further and actually make the source code available to everybody. Both models work. And this revolutionized the smartphone industry, most of our daily life. Who here uses Chrome as a web browser? Right? So that's an open source project. My co-founder, Joel, at Google X, used to work on Chrome. We have a history of working on open projects. These are projects that are very large and have transformed industries. They're companies working together. And sort of unfortunate, we don't see that in 3D printing so much, not in the way that we see it in high tech. So I just want to talk a little bit about a specific aspect of openness, which is material development. Generally, materials have been something in 3D printing, specifically polymer 3D printing, they haven't been good enough. You don't have UV stability, you don't have isotropic parts, you don't really have the properties that you need. People have been chasing nylon and ABS-like equivalents in photopolymers for a long time. And you have some great companies out there that have been there for almost 30 years developing these materials, and they've done it in a closed way, and they're not really material companies. And this is really what we see today. There's some pseudo open platforms out there, but a lot of them actually aren't developing new materials. They're using existing materials, repackaging them. So we really wanted to look at an open development model from the beginning at Origin. We think materials are the lowest hanging fruit. Going into why we think closed development of materials is just not the right approach. You have slower development. I mean, it goes without saying that some of the incumbents in this industry have been developing photopolymers and other materials for almost 30 years. And stereolithography still has a reputation for brittle parts. We have 30 years of development, and people still think the parts are brittle and not UV stable. It's because most of them are brittle and not UV stable after 30 years of development. You usually have these traditional or narrow chemistries. Has anyone heard of acrylates before? Your urethane acrylates, epoxies. Those are some of the chemistries that underlie stereolithography. And it's basically what everyone's using until some other companies have come around with some more interesting things. When you build a 3D printer, it tends to be very narrow. If you build an FDM printer, it squirts out filament like a hot glue gun. If you build a stereolithography printer, you're really building an acrylate and epoxy printer. And so this goes into, there's very limited options. And then you have single points of failure. You got to buy this stuff, these materials from that company that is making them, and you don't really know where they source the starting materials and all that. We think that this closed development model is something that needs to be left in the past. So we propose a new model. That's called open development. So basically, open development enables faster development of new materials. You'll see this if you go to Origin's booth. Since November, we have launched partnerships, which we'll talk about, with three of some of the largest chemical companies in the world, BASF, Henkel, and DSM. And in that period of time, they have developed on our platform and with us jointly, they've taken existing chemistries and improved them and developed entirely new materials. And that's what we've done with those three partners. We have close to about 10 other material partners we have not announced that are doing very, very interesting things. Rapid innovation that we're seeing is unparalleled. This is part that you would think is SLS printed, is actually printed on our platform. And this is actually done in a BASF material where BASF didn't even know this was possible. So the combination of material innovation and print process innovation has allowed us to see this unprecedented amount of innovation. Another example is some of these silicones that we see from Henkel. We were initially, earlier this year, able to print some of the most challenging formulations their parent chemistries were FDA approved. So in just a couple of months, we're able to address a lot of these markets. Because these are existing chemistries, it means the materials will inherently be less expensive than if one company were to develop them all. There's also broad chemistries. Usually when you make a material on a platform, you have a novel print process. There's some out there that use oxygen. Stereolithography, actually everything uses oxygen. Give carbon credit. They did a great job harnessing oxygen and making it useful in polymerization. But it does sort of narrow the types of core chemistries you can make. New and broad chemistries are very interesting. The other thing is redundant backup sources. So understanding your supply chain. If you have qualified materials, if anyone here, if you've done manufacturing, if you get glass-filled PBT20, you don't want to rely on one company providing that. It'd be nice. We have a customer that has hundreds of glass-filled PBT for their parts. And so they have many, many redundant backup supplies. And this is something that's built up over the years from different sources. So this is why part of the reason we believe in open development. Just over the last year, our partnerships with BASF has resulted in, they've developed the ultra-cured line of materials. These materials were improved and formulated and commercialized initially on the Origin platform, and they produce just astonishing results. You should come to our booth and see the variety of textures, the quality that we're able to achieve with these materials from BSF. I know this is just the beginning for BSF. We now have these moving assemblies. They have a range of material chemistries coming out, many of them that will take advantage of Origin's unique platform. So we're very excited about this. Another is Henkel. So this is a few months ago when we partnered with Henkel. This is a biocompatible silicone that was almost impossible to print. And so these are basically UV curable adhesives. And through a very flexible print process, rather than formulating the material for the system, we had the system adjust to print this reliably. Going back to BSF, this is kind of the other way around, where the core chemistries existed, but these were actually tuned on our material development platform. So two different approaches to do open materials. And again, this brings biocompatible materials that are their parent families are FDA approved. We didn't have to develop our own materials for 5 years and compete with Henkel on silicones. We can bring them to customers in just a couple of weeks. And we're going to talk about how quickly we're able to get from the development of materials into customers' hands into mass production. One of the advantages of open materials. Finally, if anyone's been seeing the news, last week we added a DSM as one of our partners. We launched a material. Has anyone used Perform before? So this is Perform HW. It's a brand new formulation designed, in collaboration with us, going back and forth on our material development platform. This is an open material. This is available to everybody. It's optimized for the our print process, which we'll talk about in a bit. It has in DSM's own words, the best surface finish they've ever seen. And this is a ceramic, highly filled material. It also has a lot of post-processing advantages that previous Perform did not have, which you'll see in a little bit. So we're excited. These are just examples of some materials. All these, we started work with a lot of these material companies only months ago and already have these results. DSM is an interesting company because they're one of the companies that have had a lot of these chemistries around for a long time. And you put them in a 3D Systems Viper or something like that, and it feels like the materials haven't improved. In just a couple of months, we have an improved material, marquee material from them. There's a lot more that will be coming. So again, a byproduct of the open development. And today, across the network of our partners, our 3 launch partners and all the other ones, we have resilient elastomers, biocompatible materials, optically clear materials, and super tough materials. This shows we have materials with some of these print processes. Stereolithography tends to be very clear. That's one of the things you're able to get out of it. If you look at some of these DLP-based systems or companies from or less expensive systems or innovative systems, they tend not to have many clear parts. So we're excited to see that we're getting close to optically clear on our process. We also have very resilient elastomers. So this is a great example of a material that responds instantly. It's highly responsive. A lot of the flexible materials, you can tear them. They're not very strong. This is an isotropic, highly responsive material. And unlike other materials, this post-processes in just a couple of minutes. And we'll talk again about that. And then we have some super tough materials, some of the toughest in the industry. This is where we're at today. So the blue is the standard trade-off that you see in the industry. Who here has complained about when you get a really high heat deflection material, it's brittle? Is that right? You're trying to make a mold, you're trying to make a part, especially end-use part beyond prototyping. The higher heat deflection, the more brittle it is. Well, that's because there's a standard trade-off here with these chemistries. With the acrylate chemistries that you have in stereolithography, you basically get a trade-off between the toughness and the heat deflection. This is the state of the art. In the blue also includes materials from who we believe are the most innovative companies currently in this space. One is Carbon. Some of their materials are in there. They're still in the blue. I'm happy to announce in our open material platform across all our partners, the advantage of all those partners is that yellow area is the materials that are available today. They encompass everything in the blue area and push the boundaries of what you can print with a 3D printer, especially with a high quality isotropic part that matches injection molding. Because of open material development and because of some of the process advantages we'll talk about soon, we believe that this boundary of what future materials can be is pushed way far out. So in just about a year, we're able to achieve this. We think this is going to push into that pink zone. And that's going to enable a bunch of new applications that aren't enabled today. And we're really excited about that. And the ones that are highlighted here are commercially available in the yellow. Some of the ones, there's ones in the pink that we've been testing that are very interesting. And if you're a material scientist, you notice this toughness for seat deflection. You can have this resilience versus elongation. You can have all the properties that you normally trade off. And you'll see that these open materials are world-class in every way. And again, it's because every company is good at something different, and you're getting the power of that network. You know, if Apple made every app on your iPhone, you wouldn't have Uber, you wouldn't have Facebook, you wouldn't have Twitter, you wouldn't have all those apps. So that sort of thinking of materials as applications and apps allows us to push materials further in additive today. I want to talk about something that we announced yesterday. We've been talking about materials for a long time, since November, launching partnerships. We launched an initiative called Open Additive Manufacturing. And the core thesis of that is we need to be a collaborative industry and really be open. The lowest hanging fruit is to be open on the material side. That doesn't mean be the Wild West. That means having these strategic partnerships, making better materials, taking the product, the sum of that, and offering it to customers. But there's something missing. If we're only talking about materials, you need software, you need process control, and you need a 3D printer that's capable of printing a wide variety of materials. One system that can print all these different chemistries. Because one of the issues is you buy a 3D printer for SLS, but what if you had a printer that could print parts like SLS? You buy a printer that is constrained to its chemistry with stereolithography, with DLS and other technologies as well. The idea behind open additive manufacturing is to have one hardware platform, software platform that works across this range of things, so people don't have to keep buying new stuff. And we'll go into this because I'm talking about the quality of the system. I just want to jump straight forward. But yesterday we introduced Origin One. It's a system from Origin that is open. It's open materials. We collaborate with material partners. Has open software. We want to integrate with different software platforms, CAD platforms, workflows, in-process QA, and eventually we'll have open hardware. And I want to be the first to, in person, kind of show you Origin One as an introduction.
Today's approaches to additive manufacturing are difficult to scale, inconsistent, and include time-intensive post-processing, all of which put end-use production out of reach. Introducing Origin One, a new path to additive mass production. Origin One's approach enables accurate, consistent parts with simple post-processing and an expanding array of commercial-grade materials. Origin One uses a unique technology called programmable photopolymerization to precisely orchestrate light, temperature, and other conditions to produce parts with incredible accuracy. During production, responsive algorithms continuously monitor sensor data, automatically optimizing prints in real time to provide unparalleled part-to-part consistency. Parts achieve peak mechanical properties during printing and require minimal supports, meaning post-processing is simple and fast. After printing, an under 10-minute clean and UV cure yields parts ready for end use. batch post-processing makes scaled production feasible. Origin's Open Materials Network gives users access to a wide range of high-performance photopolymers developed by the biggest names in manufacturing. Material partners leverage Origin's open platform, unique material development technology, and real-time data analytics to create new material chemistries not possible with additive today. Production monitoring and analysis reduces labor and increases efficiency. One operator can manage dozens of printers to produce thousands of parts. Origin One, ready for additive mass production.
So that, ladies and gentlemen, is Origin One, what we've been working on for 4 years. It's the combination of our software expertise, working with our material partners, creating new materials, and bringing to life a manufacturing system that can produce high-quality parts with extremely low amounts of post-processing and high throughput. What we showed in this video today is the secret, the dirty secret people never show, which is the post-processing of any system. It can take 4 hours to 2 days on a high-throughput system to bake certain chemistries from certain companies, where you have to do a bead blasting, and you go through this massive process. You put it in ovens and you bake it. And the problem with that is not just the fact that the throughput's slow, it's that you're actually doing the printing outside the printer. All that post-processing means that it's done outside the printer, and that's why you're getting warped parts and you're getting parts that aren't that great. We're trying to get to 99% cure in the printer. Some materials require UV cure just for the outside, because you're producing the entire part in the system. Eventually, we think we can get it down to just a simple clean. As you noticed, everything is easy to scale. So if you come to our booth and you see the high-quality textures, high-quality parts, you're seeing parts that don't really have support structures, that have large overhangs, that can be cleaned in 5 minutes, whether it's one part or 1,000 parts, and put on a conveyor system and bulk produced. And this is how you can produce tens of thousands of parts, hundreds of thousands of parts, millions of parts. We think it's in the process. The process control of Origin One, it has over 4 cameras in it, thermal imaging, 4K cameras. It's collecting more data than probably almost all the printers and Rapid combined. I don't know, but probably is. And that data ensures that, when you have a print, it's failing, and it just keeps going. Well, that's dumb printing. Responsive printing is more like a self-driving car. We record everything, we send it to the cloud, we do processing. Doesn't necessarily have to be cloud connected, that's another discussion. But the system responds and produces the same part time and time again by actually responding to changing conditions. And then it has built-in in-process QA. So we're able to look at the chemical reaction that's occurring in the printer. Other companies try to simulate this. We just do it, and we look at it. And when you look at it, you're able to produce a higher yield part in large volume production, and for material development, you're able to iterate much faster. In fact, we have companies, material partners, that are actually formulating in real time on our platform. Get that, formulating in real time, brand new materials. So that's Origin One. Well, let me go to my next slide here.
To include time-intensive...
I knew there would be at least one hiccup. So that's Origin One. For over 2 years, it's been in the hands of our material partners and beta customers. This is the 3rd generation machine, redesigned. It's a mature platform. It's already in the hands. We announced a partnership and collaboration with BASF and Echo. We're going to be announcing the results of that soon, and we're going to talk about that. But it's in the hands of government organizations, tier 1 automakers, OEMs, you name it. They already have early versions of the Origin One, and they've had it for many years. The new Origin One that we're releasing will go out to our beta customers starting this summer. It'll be available for general availability in the fall. So these are real systems that are in our booth. it's going into production. You don't need to wait a year. We're starting to build them right now. And they're already being used for end-use production applications. So I just quickly wanted to mention our partner, Henkel, operates under everyone's wearing Loctite bands, so they've done well on the marketing side. So there's sort of two applications that we've identified with Henkel for production. This is This is basically a motor adapter for a bioreactor. It's printed in a Loctite material on the Origin One, you basically get this commercial grade injection molded quality that is far beyond what you get of FDM. It also, the Loctite materials, the ones that's used here, is relatively tough and inexpensive, and so it's able to replace ABS, thermoplastic. The post-processing of this, whether it's one or many, is in under 15 minutes. And you can check out this part in our booth, or you can check out the Henkel Loctite booth as well. That part is there. This is, we worked with Interpro. This actually is a silicone. Some of the silicones that we're working with Henkel. We're able to produce a large number of these in a very short period of time for the customer. So less than $19 per part in a run, less than $100. Less than 100 units. These are things that we just did in the last couple of weeks. So as our partners are releasing and commercializing materials and we're getting off the ground, we have customers that we're printing for. We printed these in our lab just a few weeks ago and already have validated parts and validated chemistries in the hands of customers. And that's what open additive manufacturing is all about. Getting new materials and new partners to market and solving a real problem. And the scale is going to go higher from there. So yesterday we announced Echo is one of our premier customers. Fortunately, I can't share what they're working on, but some of you have probably noticed 3D printing has been really popular in footwear. We're really excited about this application because we think it's going to revolutionize the traditional manufacturing of footwear. So volumes of millions to tens of millions on a process that's powered by both BSF materials, the Origin platform working together in an open network, we think is a really exciting value proposition. This is one of the cases where additive manufacturing is directly lowering the costs of manufacturing, including injection molding. It's lowering the cost of manufacturing in general. It's not even about printing a different type of product. We'll have more to announce there. So with that, we continuously expand our material network. It's really important to us to have close partnerships with our customers and our partners. And we really believe that the future is going to be open. And we believe this new path, entirely new path to produce brand new materials, brand new chemistries, and have you as the customers and partners produce these parts, whether it's at a contract manufacturer, it's at the edge, it's out in the field, it's in your factory. We believe that you'll be able to get 3D printing out of the lab and get into mass production, not in years, not in months, but in days or weeks. And we're glad that we're already starting to show that this is happening. Our goal at Origin is, again, to get other partners to buy into this idea and embrace it, because we're one industry. And if we build the open platform of the future, I think we'll transform manufacturing in the way that 3D printing has always promised, but always sort of it's fell flat on. And my fundamental belief is 3D printing never lived up to its hype, not because of the technologies, but because of the business models. So we have to rethink the business models. And by rethinking the business models, we rethought the technologies and the partnerships. And so that's what we call additive mass production on in an open way. That's my final slide. So that's it. I'll answer any questions if I have any time.
You talked about the open software and the materials. Where do you see the open hardware fitting in here?
Yeah, so, I guess they're going to give me another mic. Cool.
Oh, no, I said you talked about the open materials and the open software. Where do you see the open hardware fitting in there, and what is that machine going to look like? Is it going to be more
Yep. Yeah,
pick up parts from off Amazon or something?
Yeah, so in general, the philosophy behind Origin is to be open. We want to build open additive manufacturing. The low-hanging fruit is materials. That's what isn't good enough for most end-use applications today. So that's where we started. The next step for us is open software. If we didn't have to build a 3D printer, we wouldn't. But we thought there was a lot of innovation on the hardware front. And so we had to build a print process that would work across chemistries and work in different environments. But we think that by building that system, our core philosophy is to build an open system that's open on the software side so you can integrate, open on the chemistry side so chemistry companies, material companies can innovate. We've sort of just iterated on that for many years. There's no magic bullet here. And so the Origin 1 is based on that idea. What we think is going to happen is there's going to be new innovative additive manufacturing processes. We believe they'll be reactive, so you'll be doing the chemistry in the printer like you do on Origin 1. But we think there'll be a lot of innovation, just like there is in material companies. And so to avoid our company from being disrupted, like some other companies would be, let's say if we sold our own materials, we'd be threatened by the idea of an open network for making revenue from that. We built in our model from the beginning, an open hardware platform. So it doesn't mean it's open source, but we want to invite any hardware company, especially on the reactive chemistry side, and every material partner and every software partner that wants to do additive mass production and make a lot of parts for customers to work with us together. And that means that we with open hardware, that we could see other print processes. We also think that the platforms are getting complicated enough that if you're a person in a garage, like Steve Jobs and Steve Wozniak back in the day, they built the Apple I. But today you can't build an iPhone in your garage, right? It's because the systems get complicated and there's just so much layers of complexity. That's starting to happen in 3D printing. It's happening with our system. We think it's the world's most advanced system. It's, especially all the software that it's running has a GPU in it and all this technology. We have invested a substantial amount of money in that platform. We don't think that a researcher or somebody at some of these smaller startups in the future will be able to build that from the ground up. The platforms will be decided, but they'll have new additive technology. They'll have new hardware. They'll have new ways of doing things. And just like the material companies with their materials, we want to make sure that they're able to build on top of our hardware ecosystem that we've yet to launch. So our goal is to if we're going to lay the foundation of open additive manufacturing, it needs to be open. Software, hardware, and materials. If you protect one, that's it, right? It's not going to work. And so that's what's really unique about us. And we look forward to, we're already engaging with some hardware partners that may be leveraging a lot of our technology in the future. We're excited to see those future announcements. So, any other questions? All right. Well, thanks for coming, and come to the Origin booth and check out Origin 1. Check out some of the advanced materials. BSF is in our booth today. We'll have material partners, different material partners in our booth every day to showcase that true open ecosystem. BSF doesn't have a booth here at Rapid, but you can see what they're working on at the Origin booth. So definitely stop by. Thank you.